A very good morning to everyone. I am Shubham Saini and today we will be discussing about flame photometer. So the aim of our experiment is to determine the concentration of specific metal ions like ions of sodium, potassium, calcium, etc. present in solutions using flame photometer. Now first we will understand what a flame photometer is. Flame photometer is an analytical instrument used in inorganic chemical analysis to determine the concentration of alkali and alkaline earth metal ions. It is based on measurement of intensity of light emitted when a metal is introduced into the flame. The wavelength of the color tells what the element is, and the color's intensity tells us how much of the element present. Now the apparatus used in this experiment are a flame photometer, a compressor, dropper, measuring cylinder, weighing machine and different samples. First we will understand different parts of flame photometer. First is source of flame. A burner is a source of flame that is within the instrument needed for temperature control and to heat up the solution. Second is nebulizer. It is used to send homogeneous solution into the flame at a steady rate. Now optical system. It comprises three parts: convex mirror, lens and filter. The convex mirror helps to transmit light emitted from the atoms and focus the emission to the lens. The convex lens helps to focus the light on a point called slit. The reflections from the mirror passes through the slit and reach the filters. The filters will isolate the wavelength to be measured from any extraneous emissions. Hence, you can say it acts as interference type color filters. Now last is photodetector. It detects the emitted light and measure the intensity of radiation emitted by the flame. That is, the emitted radiation is converted to an electrical signal with the help of photodetector. The produced electrical signals are directly proportional to the intensity of the light. Now, we will see the principle of flame photometer. The basic principle upon which atomic spectroscopy works is based on the fact that matter absorbs light at the same wavelength at which it emits light. The compounds of alkali and alkaline earth metals can be thermally dissociated in a flame, and that some of the atoms produced will be further excited to a higher energy level. And when these atoms returns to ground state, they emit radiation which lies mainly in the visible region of the spectrum. And each element will emit radiation at a wavelength specific for that element. When metal salt solution is burned, the metal provides a colored flame, and each metal ions gives a different colored flame. In this experiment, we take a solution containing the relevant substance to be analyzed is aspirated into the burner and dispersed into the flame as a fine spray. In the flame, the solvent evaporates first, leaving finely divided solid particles which move to the hottest region of the flame where gaseous atoms and ions are produced. The atoms are excited by absorbing energy available from the flame. As the excited atoms returns to a ground state of lower energy, radiation of wavelength characteristics of the element is emitted. Each alkali and alkaline earth metal has specific wavelength. The table gives details of the measurable atomic flame emissions of alkali and alkaline earth metals in terms of emission wavelength and the color produced. Now we move to the procedure. First, we will look at sample preparation. There are some points regarding sample preparation which should be adhered to in order to achieve the required accuracy in your analysis. First is, you should avoid handling samples with fingers. This leads to serious contamination. Second, standards and samples should not be exposed to the atmosphere for long periods due to contamination from airborne particles and the evaporation of the solvent, which could lead to elevated concentration. You have to wash properly all the volumetric flasks and beakers for preparation of solutions. Now for preparing sample, we have to do some calculations also. As you all are aware, ppm is a term used to denote a very low concentration of solution, and 1 ppm is 1 milligram per liter. Here we are preparing 1000 ppm standard of potassium using the salt potassium chloride. You can go through this formula and calculations. So the amount of potassium chloride to be mixed with 250 ml distilled water to get the standard solution of 1000 ppm is 476.73 milligram. And in order to prepare 100 ppm standard solution of potassium, we have to take 10 ml of solution from 1000 ppm solution and mix it with 90 ml distilled water. And finally, for the preparation of 50 ppm standard solution of potassium, we have to take 50 ml solution from 100 ppm solution and mix it with 50 ml distilled water. So this is how you will prepare two standard solution of potassium. Similarly, you can prepare the standard solution of sodium as well. Now let's move to the experiment. For measuring weight, we have analytical balance here. First, we will measure the weight of butter paper and we reset the readings to 0 by pressing the tare button. For best results, try to weigh by closing the door of the balance. Here we are measuring potassium chloride salt to be mixed with 250 ml distilled water to prepare standard solution of 1000 ppm. As you can see, we have accurately measured 476.7 milligram. After measuring, we have to carefully pour this salt in a 250 ml flask. Now we add some distilled water to it. And shake it well. Now again, we add more distilled water and fill the flask up to the mark. So this is our 1000 ppm standard solution of potassium. Now, in order to prepare 100 ppm standard solution of potassium, as discussed earlier, we will take 10 ml from 1000 ppm solution. With the help of dropper, we can accurately measure 10 ml and pour this solution in a 100 ml measuring cylinder. Now fill the measuring cylinder with distilled water. You can use dropper also. Now pour this solution in a small beaker labeling potassium chloride 100 ppm. So this is our 100 ppm standard solution of potassium. Similarly, we can prepare 50 ppm standard solution of potassium by taking 50 ml from 100 ppm solution and adding 50 ml distilled water. Now pour this solution in a small beaker labeling potassium chloride 50 ppm. Now all our standard solution of potassium are ready. Similarly, you can prepare standard solutions of sodium as well. First, the air out of compressor unit should be properly attached to the nebulizer of the atomizer. Switch on the air compressor unit. Adjust the air pressure to about 0.6 kg per centimeter square by rotating the air control valve in anti-clockwise direction. The gas connecting the tube should be connected properly from the LPG cylinder to the instrument. Turn on the LPG gas regulator by turning the gas control valve in anti-clockwise direction. Now switch on the flame photometer unit. Switch on the flame failure switch to enable the flame failure indication alarm. Press the auto ignition switch and keep it pressed Turn the fuel gas regulator of the instrument anti-clockwise slowly. The element comes on the top of the burner and turns red. The gas lights up. Adjust the fuel gas regulator to get silent flame close to the burner with sharp blue cones. Now there are 4 options in the main menu: analysis, setup, calibration, and miscellaneous. Analysis option is used to analyze the unknown sample. Before the sample can be analyzed, it is necessary to set up, followed by the calibration of that particular setup. Now, setup. This is the first necessary step before any calibration or analysis is performed. The instrument can store up to 10 different setups at any point of time. Creating a setup is like creating different files in which one can specify different parameters like number of elements, their standard values, etc. Once a setup is created, it can be used for calibration followed by analysis. Now, calibration. Once a setup has been created, it is necessary to calibrate it before doing analysis. All the necessary calibration data like number of elements and then corresponding number of standard for each element, the standard values, etc. are taken from the active setup. Next is miscellaneous. This option is used for performing the miscellaneous functions like setting of clock, setting the proper flame, and various printing options. Now we press the numeric key 2 to select the setup option. The display shows select setup screen. The setup, which is already filled up, will have a checked symbol in front of it. For selecting any setup, press the corresponding numeric key. For instance, press numeric key 5 to select setup 5. The display shows the select mode. Here we have general mode, serum mode, and urine mode. General mode is selected for performing the test in ppm mode. Serum mode is chosen for estimation of the elements in blood serum. And urine mode is chosen for estimation of sodium, potassium, and calcium in urine samples. The arrow in front of the option shows the currently selected operation mode. Press enter key, the display shows select menu. Enter the dilution factor by using numeric keys. The dilution factor has to be same for all selected elements in a setup. Choose the unit of measurement. Since our unit is ppm, press the enter key. The display shows select elements. This is used for selecting the elements in the current measurement. To select an element, press the corresponding numeric key displayed in front of the element. The checked symbol shows the element is selected. Press the same key to unselect the element. After selecting the elements, press the enter key. The display shows number of standards. Press the numeric key say 2 for potassium and enter the number of standards, say 3. That would be used for its calibration. But here we are using 2 standard, so press 2. Now press enter key. The display shows standard values. Now enter the standard values of element in the selected setup. Here they are already filled, so press enter key. The display shows save setup. The old setup and its data will be overwritten. Press enter key if the data entered in the correct setup is to be saved. It will overwrite any data previously entered for this setup. Saving this current setup will also erase any samples that are stored in the memory for this particular setup. Press escape key if the setup was just to be viewed and the old setup data is not overwritten. Since we want to save this data, we will press enter key. After this, the system returns to the main menu. Now we will do calibration. Press numeric key 3 to select calibration. The value of the last setup chosen is automatically displayed. Press the corresponding numeric key to select setup for calibration. In our case, it is 5. Now press enter key. The display shows aspirate blank solution. Now put the capillary in the blank solution, that is distilled water, and press enter key. Aspirate the standard solution with concentration of elements shown on the display. As it is showing potassium 100 ppm, so we put the capillary in 100 ppm solution and press enter key. The display shows processing, please wait. The system then one by one asks for more standard solution as per the data entered for the selected setup. Now put the capillary in the distilled water and press enter key. Now aspirate the 50 ppm standard solution of potassium. Press enter key. Again put the capillary in the blank solution, that is distilled water, and press enter key. Now calibration is over, as the display is showing calibration done, and the display returns to the main menu. Now press the numeric key 1 for analysis. The display shows select setup. The value of the last setup chosen is automatically displayed. Press the corresponding numeric key to select the setup for sample analysis. In our case it is 5. Now press enter key. The display shows 05/01/00, which corresponds to current setup, current batch number, and current sample number respectively. If the batch or sample number is required to be changed, it can be done with the help of numeric keys 1 and 2 respectively. Now press enter key. Now the display shows aspirate sample solution. As we have already put it the capillary in distilled water, press enter key. Now put the capillary in the sample solution. Press enter key. The display shows processing, please wait. Now here are the results. The result is very good. You can note down this. Now again we put the capillary in distilled water and press enter key. Again it is showing batch number and sample number. Press enter key. Display shows aspirate blank solution, which is already there. Press enter key. Now we put the capillary in the sample solution of 100 ppm and press enter key. And you see the results. The potassium is 99.2 ppm. So this is how we confirm our standard solutions are prepared accurately. Again we repeat the same steps for two unknown samples, that is for tap water and RO water. Now again put the capillary in distilled water and press enter key. Again press enter key. Now aspirate the blank solution. Press enter key. Now put capillary in unknown sample and press enter key. So we find out the content of potassium in the sample is 1.5 ppm. Again put capillary in distilled water and press enter key. Now aspirate blank solution, which is already there. Press enter key. Now put capillary in unknown sample 2 and press enter key. So here are our results. Last we will check the potassium content in distilled water. Repeat the same steps. Here our sample is also distilled water. Press enter key. Ideally it should come 0, but it is okay. Now press escape key and the display returns to main menu. Now we have to switch off the whole system. First, we switch off fuel gas regulator of the instrument by moving it in clockwise direction. Switch off the gas supply using the gas regulator fitted on the gas cylinder. Switch off the compressor. Switch off the main unit. That's it. Now these are the results. You can go through this. Now, flame photometer has lot of applications. Some of them are mentioned here. Flame photometer can be applied both for quantitative and qualitative analysis of elements. The radiations emitted by the flame photometer are characteristic to particular metal. Hence, with the help of flame photometer, we can detect the presence of any specific element in the given sample. The presence of some group second elements is critical for soil health. We can determine the presence of various alkali and alkaline earth metals in soil sample by conducting flame test, and then the soil can be supplied with specific fertilizer. The concentration of sodium and potassium ions are very important in the human body for conducting various metabolic functions. Their concentration can be determined by diluting and aspirating blood serum samples into the flame. Soft drinks, fruit juices, and alcoholic beverages can also be analyzed by using flame photometer to determine the concentration of various metals and elements. Apart from these, it is used in determination of lead in petrol and in determination of calcium and magnesium in cement. Now, we have some advantages of flame photometer. The method of analysis is very simple and economical. It is quick, convenient, selective and sensitive analysis. It's both qualitative and quantitative in nature. Even very low concentrations like ppm of metals in the samples can be determined. This method can be used to estimate elements which are rarely analyzed. In spite of many advantages, this analysis technique has quite a few disadvantages also. The accurate concentration of metal ion in the solution cannot be measured. It cannot directly detect and determine the presence of inert gases. Though this technique measures the total metal content present in the sample, it does not provide the information about the molecular structure of the metal present in the sample. Only liquid samples may be used. Also, sample preparation becomes lengthy in some cases. Flame photometer cannot be used for the direct determination of each and every metal atom. There are a number of metal atoms which cannot be analyzed by this method. The elements such as carbon, hydrogen and halides cannot be detected due to their non-radiating nature. Now you have to follow some precautions, like make sure that the unit is properly connected to the gas cylinder and there is no gas leaks. Ensure that the correct gas regulator is used and connected properly. It is not recommended to leave the flame photometer unattended during operation. Now this is very important. Don't look down the flame chimney when igniting or operating the equipment. Allow sufficient time for the chimney to cool before handling and make sure a fire extinguisher is located nearby that can be used in case of emergency. So that's it for flame photometer. Thank you.